Hello and welcome back. So we'll continue looking at solving linear inequalities, looking at a few special cases that can turn up. So here we have an inequality. 3 times x plus 1 is greater than 3x plus 2. So if I distribute the 3, I'll have 3x plus 3 is greater than 3x plus 2. So I'll get all my x's on one side, I'll subtract the 3x, and everything sort of cancels here. So I'll have 3 after the 3x and the negative 3x cancel. It's greater than 2. Now if we sit back for a second and we ask ourselves, what does this mean? 3 is always greater than 2. So this is always true. So it doesn't matter what x is. If x is 0, this is true. If x is negative 10, this is true. If x is 137, this is true. It doesn't matter what x is, what values of x this is. So this is always true. So one way to say this is that every x is a solution. So we can express this in terms of an interval as well. So what I want to do is to say every x from negative infinity up to positive infinity. So this is just the interval that is the entire real line. As in, if here's 0, and let's say negative 1, negative 2, 1, 2, and so on and so forth, this interval from negative infinity to infinity is just every single number. Everything solves this equation because it's always true. And there's not a whole lot more that can be said for that one. Here we'll look at the opposite sort of case. X plus 1 is less than or equal to x minus 1. Okay, so let's subtract an x from both sides. And then we get 1 is less than or equal to negative 1. This is never true. So no matter what x you plug in here, this will never work. So no x is a solution. So here we would want the empty interval or the empty set. So this is the empty set, meaning a set with nothing in it, because there are no solutions. The solution set is just empty. So be careful. You might come across equations like this, so you'll just have to recognize, oh, is every x a solution? Is no x a solution? Or is it just some of them? We can also string together inequalities, and you would approach this in the same way that you would approach any equality. And I will mention another way to solve this in a second, but for right now, we just have 2 inequalities strung together, and we want to get x by itself. So for instance, I need to cancel out this plus 3. So if I subtract 3 from this, I want to do this in every section of the inequality, on the left-hand side, in the middle, and on the right-hand side. So anything that's separated by an inequality sign or an equality sign, you just have to apply the same operation. So here if I subtract 3 from the middle, I just get 2x. On the right-hand side, I'll get 8, and on the left-hand side, I'll get negative 2. Again, I want to divide this middle section by 2, so I simply have to do that to every single one. So 8 divided by 2 is 4, 2x divided by 2 is x, and this last one will be negative 1. And then here we can use one of our finite integrals as well. So here this is going to be all of the x's from negative 1 up to 4. We're going to include negative 1 because it's or equal to it, but we're not going to include 4. So again, on our number line, we have all the numbers from negative 1 up to 4, including negative 1, not including 4. Okay, so we can string equalities together, and that's going to help us with the following thing. Inequalities with absolute values. So here I have the absolute value of x is less than 2. So let's just think about this for a second. What sorts of things could I plug in here? Well, if I plug in a 0 in here, the absolute value of 0 is 0, so 0 is less than 2. That's true. So 0 is the solution. If I plug 1 in here, the absolute value of 1 is less than 2 because the absolute value of 1 is 1. If I plug 2 in here, 2, the absolute value of 2 is not less than 2 because 2 is not less than 2. So 2 is not a solution. Negative 1 is a solution. If I plug negative 1 into the absolute value of negative 1 is positive 1, and positive 1 is less than 2. So that's also a solution. Negative 2 is not a solution because if I plug a negative 2 in here, the absolute value of negative 2 is equal to 2. So 2 is not less than 2. And you can begin to see that our solutions are going to be anything in this region here. If you plug in something outside of this, like a 3, the absolute value of 3 is 3, and 3 is not less than 2. The absolute value of negative 3 is also 3, and 3 is not less than 2. So our solutions are trapped in this little region here. So the solution set will look like anything from negative 2 up to 2, not including 2. Over here, we have the opposite case. Now I want the absolute value of x to be greater than 2. So for instance, 3 is a solution because the absolute value of 3 is 3, and 3 is bigger than 2. And the same goes for negative 3. The absolute value of negative 3 is 3, which is greater than 2. But if I plug in 0, the absolute value of 0 is 0 and not greater than 2. So if we stare at this long enough, we can begin to see, oh, anything bigger than 2 or smaller than negative 2 will work, because when you take the absolute value, they become positive and bigger than 2. Anything smaller than 2, or I should say between 2 and negative 2, won't work in here. So here the solution set will be anything bigger than 2, not including 2, or anything smaller than anything smaller than negative 2, not including negative 2. And because both of these sets are in the solution, we're going to take the union of them. We're going to put them together. So let's look at this and come up with a theorem here. So when we're solving absolute value inequalities, we can apply the following. When c is a positive number, if the absolute value of u is less than c, u is going to have to live between c and negative c. It's the same thing that we saw up here. The absolute value of x is less than 2. X has to live between 2 and positive 2. If the absolute value of u is greater than c, this means that u is either going to be very small or very big, smaller than negative c or bigger than c. Again, up here, if the absolute value of x is greater than 2, then either x is really small and less than negative 2, or it's really big and greater than 2. So let's apply this. We've got the absolute value of x minus 2 is less than 5. Okay, so the absolute value of something being less than 5, this means that this expression is going to be trapped between c and negative c. So again, the absolute value of x minus 2 is less than 5, means that x minus 2 will be between 5 and negative 5. And now I solve this just like I would anything else. I will add 2 to cancel out that plus 2, so I'll get x is between 7 and negative 3. So my solution is all the numbers between negative 3 and 7, not including 3 and not including 7. Okay, let's look at another one. Okay, we've got a big expression here. What I'll do is I will solve for my absolute value so that I can apply what we just learned. So to get this by itself, I'll move the 20 to the other side by subtracting 20 from both of these. So 20 minus 20, 0. Negative 19 minus 20 So this will be negative 39. Now we'll divide both sides by negative 3. And what I said should just be ringing some alarm bells. We're dividing by a negative. Which means that we're going to have to flip the inequality. So what was a greater than or equal to sign is now going to be a less than or equal to sign. So the negative 3 cancel out. So we'll get 5x minus 2 is now going to be less than negative 39 divided by negative 3. Well, that's 13. So now 5x minus 2 is less than 13. This means 5x minus 2 is going to be trapped between 13 and negative 13. Again, let's add 2 everywhere to cancel that out. So we'll get 5x is less than 15, but greater than negative 13 plus 2, that's negative 11. And finally, we have, I'll divide everything by 5. 15 divided by 5, well, that's 3. The 5's cancel out. And over here, not much we can simplify. Negative 11 divided by 5. So our range is anything from negative 11/5 up to 3, including both endpoints, because these are all less than or equal to's. Our last one here will require a little bit of work. What I'm going to do is I'm going to flip this over so that it's a little bit easier to see. So 6 minus 3x, the absolute value of 6 minus 3x has got to be greater than 18. Note that I just flip the sides. So this is smaller than this, so this is smaller than this. 6 minus 3x, the absolute value of 6 minus 3x has to be greater than 18. Well, if it's greater than 18, either it's really positive or it's really negative. So one of these two situations is true. This is either a really big positive number or it's a really small negative number. So let's solve these. Let's subtract 6 from both sides to get negative 3x is going to be greater than 18 minus 6 is 12. And I'll divide both sides by negative 3. Oh, dividing by a negative number, flip the inequality. So negative 3 cancel. 12 divided by negative 3 is negative 4. And now I have to solve this side. So again, I'll go through roughly the same steps because they're roughly the same numbers. The 6 and minus 6. But now I've got negative 18 minus 6. Well, it's going to be negative 24. And I've got the negative 3x. Divide both sides by a negative number. Careful. Switch the inequality. So x will be greater than 8. So if I write this down, this is going to be every x that's less than negative 4. So from negative 4 down. Or all of the x's that are bigger than 8. So everything from 8 up. Not including 8, not including negative 4. And the solution could be in either of these. So we're going to take the union of those. And there is one final word problem that I want to go through, so I'll make a quick video, quick fourth video on that.